chapter 14, the last chapter. Solutions. So the quote here will hopefully make some more sense when we get to a later section of this chapter. One molecule of non-saline substance held in the solvent dissolved in 100 molecules of any volatile liquid decreases the vapor pressure of this liquid by nearly a constant fraction, nearly 0.0105. Really not sure why they chose that quote, but there it is. So if you were stranded on a boat in the middle of the ocean without any supplies, you'd be getting thirsty, right? And so here you are surrounded by water, but you can't drink it, right? Not just because it tastes terrible, but, so you're dehydrated, you need water, but if you drink seawater, it'll actually make you more dehydrated than not drinking anything. And part of what this chapter is about is understanding why that happens. So seawater is considered a thirsty solution, meaning it pulls water to itself. So seawater is a solution. A solution is a homogeneous mixture of two or more substances. In the seawater, we have water being the solvent, a major component, and sodium chloride is the main solute, the minor component. And then there's a whole bunch of other things dissolved in seawater as well. So we've got water and we've got sodium and chloride ions in there. Well, nature has a tendency towards mixing, unless it's highly unfavorable energetically. So here, this looks to me like maybe an aquarium, right? And so we have fresh water here, and we have seawater here, salty water, and there's a barrier. And you can imagine pulling that barrier out very carefully, not to disturb the solution, not to shake it up a lot. Would the salt water stay on this side? Or would it gradually mix together? It's gradually going to mix together, right? We kind of instinctually know that. So it's going to take a little time, but it will eventually mix and come to a uniform concentration. And a lot of the natural world is like that. It takes two things that are different, and they will naturally become the same temperature, right? Or here, the same concentration. So we can think of getting dehydrated by drinking seawater in terms of nature's tendency towards mixing. So we're looking at the intestines here, which, technically your digestive tract is actually outside of your body, right? Because we're kind of a donut, right? There's a hole going all the way through. Sort of interesting. So this is technically on the outside of your body. And so this is inside your cells. There's water and there's sodium ions and chloride ions. Are you okay?
It took me a second, but that was good.
Okay. It seems kind of obvious to me, but I think a lot of people don't realize that, right? Anyway, and so here would be inside your intestines, the seawater that you've consumed. So this has a higher concentration of salt than this does. And so just like in the aquarium, there's a tendency to mix, right? And the water can go through the cell membrane. And so the water will go through the cell membrane, effectively diluting what's in your intestines, trying to get them to be the same concentration. So what does that do to your body? It takes more water out of your body, causing you to become more dehydrated. Any questions?